Let's pick up where we left off, chapter 15. Here are some common IV solutions. They're abbreviations. I got them right out of your book. So if you're not familiar with them, you can look them up. For example, D is for dextrose, W is for water. So be familiar with those abbreviations. When you see D5W, for example, this is dextrose in water. And what this means is out of every 100 milliliters, there's 5 grams of dextrose. So when you see that, you will know the what it's made of and how much solute is in the solvent. Speaking of solutes and solvents, tonicity is talked about in your chapter 15. There's isotonic solutions where the solvent and solute are equal, such as in normal saline and D5W. We use that when we need to expand fluid volume or maintain fluid volume. Hypotonic, such as half normal saline, is when the solvent exceeds the solute. For example, if you need to dilute excess electrolytes in the body. Hypertonic, such as D5LR, the particles are more than the solvent, and this is when you need to correct imbalances that a patient has from diarrhea or vomiting. IV fluids can be given peripherally or centrally. Our job, besides knowing, what they're getting, if it's compatible, if it's at the right rate, all that, our nursing care per se is to check the fluids and the site every 30 minutes to 1 hour. There are primary and secondary IV fluids, and this primary is what's running usually 24 hours a day. Secondary or intermittent or piggyback, like antibiotics, for example. And they each have their own special tubing. And it will say on the packages primary or secondary. Blood tubing also has its own special tubing just for blood, and it has a filter in it to collect any particulates. And blood can only be run with normal saline. Here's an example. It doesn't even tell you what IV solutions. In this case, it doesn't matter. You're to give 1,000 milliliters over 8 hours. Volume over time in hours. Milliliters over time in hours is going to give you 1,000 milliliters divided by 8 hours is 125 milliliters an hour. And you program this number into the pump, because the electronic pumps in the hospitals are programmed for milliliters per hour. These are just some examples of pumps you may see. Let's work another one. You can always pause this and work it at your own speed, so I'm just going to go straight through. If you have a liter of D5W, it needs to go in 10 hours. Remember, this is milliliters per hour, so 1 liter is 1,000 milliliters divided by 10 hours equals 100 milliliters per hour. And we use pumps. It's a safety issue, but we do continue to teach manual control of IV fluids. This is where we need to calculate the drip rate, and the formula for that is volume over time in minutes times the drip factor. Now the drip factor is a number that is located on a package, and as you can see here, it is 15 on the left side and 10 on the right. So you get that number right off of your IV tubing package. Drip factors 10, 15, or 20 drips per milliliter are called macro drips. If I'm going to give you a word problem using macro drip, I will have to give you the number 10, 15, or 20 as the drip factor. 60 drips per minute is the micro drip. If I say micro drip, it's always 60. All right, here's an example of D5W going at 125 milliliters an hour. And the drop factor on the package says 10. So we want to calculate drips per minute. And I put down the formula again. So the volume over time in minutes times the drip factor. So 125 milliliters divided by 60 minutes times 10, which is the drip factor, is going to equal 20.8 or 21 drips per minute. Remember, you can't have a partial drip. So on your test and in real life, the answer you will give me is not going to be 20.8 drips per minute. It will be 21 drips per minute. All right, so here's one, D5W at 50 an hour using microdrip tubing. What did I say about microdrip? It's always 60. So we're going to have 50 milliliters divided by 60 minutes, because 50 milliliters per hour is 50 milliliters per 60 minutes, times 60 equals 50 drips per minute. Now when we get into the lab, I want you to have your second-hand watch. We will hold it up. If you need to have 50 drips per minute, you will hold your watch up to the drip chamber and you will count for 15 seconds. All right, and so if you get about 12 drops in those 15 seconds, and then you've got to do that 4 times, so 12 times 4 is 48, so that's about 50 drips per minute. Moving on to the next topic is adjusting IV flow. Typically your IV fluid rates will not get behind unless your IV has infiltrated and you've got to get another IV started and you've had a hard time getting it started. So we're going to say here in this example that you've got an order from the doctor to have 1,000 milliliters go in 8 hours. So that's 125 milliliters an hour. After 4 hours, you notice you have 600 left. So it's not going at the right rate for some reason in this example. So you're going to need to recalculate it. So how we're going to do this, let's say we have a pump. Then we know 600 milliliters is what's left. Over how many hours do we have left to go? We have 4 more hours. So 600 divided by 4 is 150 milliliters an hour. And that's what you program into a pump. But we're going to walk it out one more step and say, okay, we don't have a pump. So then we would calculate further and say 150 milliliters divided by 60 minutes times the drop factor of 10, which was given in the word problem, is 25 drips per minute. Earlier we talked about some secondary fluids, also intermittent fluids can be called. And in this example, it's an antibiotic that needs to, that's in 100 milliliters. It needs to go in 30 minutes. And it's a secondary, and you look at your tubing package and it has a drop factor of 20. So you're going to have 100 milliliters divided by 30 minutes times 20 drips per milliliter equals 66.6 or 67 drips per minute. Okay, and this is assuming that you don't have a pump to put it on. Now we're going to talk just a second about IV push medications. It's the most dangerous, potent route. You have to give it just like the book says. So here is an example on here. Ativan, 3 milligrams, IV push, 20 minutes preoperatively. It comes in 4 milligrams per milliliter. So let's just figure out how many milliliters we're going to give. It's going to be 3 desired over half times quantity. So 3 over 4 times 1 is 3/4 or 0.75 milliliters. Okay. Now the book tells us we can't give it faster than 2 milligrams a minute. Let's look on the next slide. So here's where we figured out up here that we need to give 0.75 milliliters. But now we need to figure out how fast we can give it. We know we can give 2 milligrams over a minute. So how fast can we give 0.75? We actually can use the same formula with desired over half times quantity. So we know we have, desired is 3, okay? 3 milligrams. And then the half times quantity is what we know the drug book said, is 2 milligrams per 1 minute. So if you do the calculations, you can give 3 milligrams over 1.5 minutes. Let's look here. Here's another example. And here the order is for 1,500 milligrams. We have it supplied in 2-gram powder, which is 2,000 milligrams. Each 1 gram, so 1,000 milligrams, is in 10 milliliters of water. So 2 grams is going to be in how many milliliters of sterile water? 20, right? Okay. So let's look at you have 1,500 desired over half times quantity, which equals 15 milliliters. So how fast are we going to give it? We still use the same formula, the desired, and the book said we can give 1,000 milligrams over 5 minutes. So 1,500 milligrams we can give over 7.5 minutes. I know I'm throwing a lot at you. I got these examples out of your book, and I do want you to work some, which we'll talk about in a minute. Calculating infusion time. So D5W 1,000 milliliters, going at 60 an hour, and you want to begin it at 6 a.m. What time will it be finished? Well, you think 1,000 milliliters over 60 milliliters an hour, and that's going to tell you 16.6 hours. So how many hours, what part of an hour is 0.6? So 0.6 times 60 is 36 minutes. So 16 hours and 36 minutes, or 22:36 p.m., 22:36 completion time, 10:36 p.m. So I want you to work, this comes from chapters 11, 12, 14, and 15. And these are different problems that cover each of the type of problem we've done. So I would like for you to do those and bring those to class next week. Please practice, 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 bring questions to class, and we will go over it some more. Thank you.